Hello and welcome to Mechanical Why. Here I have a Saturn V rocket. It uses multiple stages to launch into orbit, and still more to get to the moon. Here is an X-33 experimental launch vehicle. It reaches orbit using only a single stage. So why do some rockets use multiple stages while others try to use only a single stage? First, let's look at what a stage is. A rocket stage consists mainly of engines and propellant tanks. The first stage fires and propels the rocket upward. When the propellant tanks are empty, the stage separates from the rocket and it usually falls back to Earth and is typically not recovered later. Then a second stage takes over with its own engines and propellant tanks. Then when this stage is spent, it too separates and falls back to Earth, also typically not recovered. And then the next stage takes over with its own engines and propellant tanks. And this continues for the total number of stages that the rocket has. If a rocket uses a single stage during launch, no parts are discarded. The same engines and propellant tanks are used throughout the entire launch. So why do we use multiple stages? It has to do with efficiency. A rocket has to carry its entire lifetime supply of propellant from the start. Imagine if you buy a new car and it comes dragging a tanker containing all of the fuel that you're going to use over the next 10 years. At first it would be very difficult to pull because it is too heavy, so a large engine is needed. But after a few years the tanker is half empty and you don't need such a large engine. And toward the end of the car's life the tanker is almost empty and you're dragging around a lot of dead weight. Wouldn't it be nice if you could discard empty parts of the tanker and downsize to a smaller engine to make it easier to drive? The same principle applies to rockets. After a certain amount of time, the tanks are partially empty, and you don't need such a large engine to keep accelerating the rocket. So we design rockets to use a certain amount of propellant, then discard the larger engines and empty tanks, and fire a smaller set of engines. Then after a certain amount of time, those tanks are empty, and we discard those for the next stage. Ideally, a rocket would have an infinite number of stages. As soon as a certain amount of propellant is burned, you won't need to carry all that extra tank and you won't need such large engines to propel it, so you can discard those for a smaller set. But this is impractical. We can't actually build infinite stages, so we settle for a limited number. But most rockets only use 2 to 3 stages, or maybe 4 to 5 in some rare cases. Why not 10? Why not 100? Or why not 1,000? The answer is complexity. Each stage adds more components. The more components, the greater the chance that one of them may fail. A single stage to orbit has far less complexity. Furthermore, it does not discard or waste any parts of the rocket. So while it is less efficient with the amount of fuel it uses, it is more efficient in that it does not waste any parts of the structure, and is likely to be far more reliable. So which is better? Well, I would personally like to ride the more reliable rocket. But we've had some engineering problems designing a single stage rocket. So right now, multiple stages are far more reliable. And just to prove that point, the Delta II is a multi-stage rocket that has to date launched 153 times and has only failed 2 of those times. That is far more safe than all manned missions launched in the United States combined. Well, thank you for watching. I hope you found this interesting. If you did, please like and share this video, and please subscribe to stay up to date on new content. Also, visit us on our website, www.mechanical-y.com.